my magnetic segments, my drive segments that I've been working on, and I thought, I wonder. So obviously the segments having the ability to, oh, I've got it wrong way around, the ability to sort of propel, right? It took the whole thing with it there, look. So right, so last night thinking about my segments, I thought, I wonder what would happen, because do you remember my anti-drag generator, this thing here, which was in the bedroom, and the arrangement of the segments on here, which I did originally, which was the steel shims, and I thought, well, I've got all these different ones, obviously, and I've got these are the nanocrystalline core materials in there, right? And I did all these different previous segments, if you remember. These are the individual segments which I've taken out. And what I'm thinking about was in the new year, well, 2022. Oh my God, I can't believe it, we're in 2022 almost. So I was thinking, now, if I take all the magnets out of the central stator, so if I remove all of these magnets out of the stator section, let's just take this canopy off a minute. Let me take this canopy off, because get this off. Obviously there's no coil on that one. And if I make new segments, new inserts on my drums that use that configuration for the magnet drive segments, and I arrange it so that we have the field pointing outwards to generate power for the coils, can we make it so that these things will, because this thing has very little drag on it, right, but it does cog a bit because of I've got a lot of magnets in there right now, and it does have a bit of a cogging issue until I get it going. So I want to try that in the new year. I want to try that to see if we can actually get this thing to produce some power. Let's just try and get this thing spinning a bit. It's difficult doing this with one hand. Let me just connect the juice up down here. I want to get this thing moving a bit first. Got the clip on yet. Ah! Damn it. Shit, hang on. Couldn't get the clip on fast enough because it was going to stop. So turn this mirror on, so it's actually coming up to a volt. Just a minute. Ah, stupid thing. So yeah, I'm in the middle of cleaning my table off right now. I moved the grinder out of the way, so that thing's producing 1 volt right now. It's picking up speed. So I really want to, I'm just running off these batteries right now, which is what, about 11 volt. Ooh, my leg, I can't get up. I'll just crouch. So it's producing 1.1 volts AC right now. And you see, I never finished this. I was in the process of designing this thing, right, and making it, and I decided to sidetrack and do some work on the magnet motor project. But we can hybridize things. So if I arrange it so that we have the magnets in the central point in the same arrangement as the segments on my magnet segment drivers, right, but we have propulsion on the ends here, which produces a good feel. But obviously when my magnetometer arrives, it's going to make it a lot easier to calibrate things, because remember, I didn't really explain that the whole concept of the magnetic mirror, I don't think, properly. So if I stick this on current right now, (63 milliamps), 62.7. You see very little slowdown on it. It's very slow, very little slowdown on the actual unit. It's actually quite efficient, really. So we're short circuiting the output coil right now. So my arm's shaking, I can't keep my hands still. I had some issues with the canopies catching the drum, so at some point I want to redesign I want to make the drum a bit smaller. I'll try and explain the principle of the magnetic mirror on these nanocrystalline deflectors on the back, because I don't think people understand that. So we're shorting out the coil right now. Let's go back to volts. I'll go on the 2 volt range. As you can see, it has very, very, very small amounts of drag on it. So it pivots the magnetic field, it rotates the field. Think about the mirror, right? The mirror effect is that everything that you see in the mirror is an opposite, is an opposite to what you actually are. When I'll turn my meter off so we don't run the battery down. I want to get up. Oh, on my knees. So if I can try and move this thing out of the way, let's just. Right, I've got my pad, my piece of paper, because I'm going to try and explain it. It's not easy to explain. I think I have to save my batteries actually. I'll plug it. So, pen. Alright, so let's just do this bit. Right, the deflectors. These are the deflectors on the back. Right, so like this. Then we have our coil. Let me just draw a little thing like this. So we have our coil, right? So I'm just doing some little wiggly lines here for the coil, right? And then the actual segments that are, we have our stationary magnets in the inside, which basically sort of like this. So which is like sort of south, and then north, sort of thing. Right, so what's happening is the part that's in between the magnets, we have an actual change. So as the segments are traveling through here, right, what we have is on the entry side we have a magnetic field which is angled at this pitch like this as it's coming in, and as it leaves at the other side it pitches back, it reflects on the other side. So this is the angle of the magnetic field that's going through the core material as it's passing. So as it's entering, the field is going in this sort of angle. Now these deflectors just switch the field around, so what we get is a pivot action, so that the angular twist of the field is that as it's entering, we have this plane of angular field, and it's going through these little deflectors. As it passes through, as the core material is passing through in this direction, it's very hard to explain it. This line, this angular momentum is pivoted in a different plane. It twists and moves to this angle because it's actually pivoting around the axial of these reflectors. So as the field is entering this point here, we have field traveling in this direction through these deflectors at the back, and as the core material is moving continuously in this direction, instead of it going through that way, it reverses and it actually goes in the other, or I'll use this other one over here to show you, it actually goes in the opposite direction. So the field is actually pivoting. It actually moves in a different direction. So the circuit of the magnetic field is entering this end of the thing, and it's moving in moving in this direction. So it actually mirrors the effect as it's travelling through, because these little deflectors, these things are on the back of the coil, so it does the opposite to the lens effect. So what you end up with is virtually no drag. The only drag that we do see is the influence of the coil, which is on this side, directly influencing the rotor as it's moving through, as in these things. As they move, we have some influence between these and the front end of the coil on the inside, but the reflectors on the outside are actually compensating for that lens effect. So I wanted to explain that, because it's difficult to explain. It's very, very difficult to explain, because there's multiple things going on all at once. We have the distortion of the magnetic field on the entry point going through. As I say, the field is angular. It's the magnetic field is travelling at this angle towards the core material as it's approaching. Then it twists back because it's moving towards the coil. The coil obviously is what's influencing the field. Then it flips around to this other angular as it's moving through. So it's difficult to explain. I'm sorry. I'm doing the best I can. Anyway, I just thought I'd explain that. So anyway, in 2022, hopefully we can... Well, I'm going to start modelling something so that I can incorporate my segment magnets put some in there because I wanted to see what it does. I really want to try this out on that particular design to see what it does. See if we actually have a more efficient system producing energy. Anyway, I'm going to go back and watch some snooker. Anyway, I hope you're all having fun. Right, see you later. Bye for now.